Good morning, or afternoon, as it's almost afternoon. We're going to start 5.2, which is ratio tables, by first comparing it to 5.1, which you just completed. So I'm going to skip down to activity 2, or I'm sorry, 3. Here's activity 3 in 5.1. It says, work with a partner. You mix different amounts of paint to create new colors. Write a statement that describes the relationship between the amounts of paint shown in each diagram. Okay, so what we did was we counted and we said that there are 4 parts blue for every 3 parts green. That's great, but what if we wanted to mix twice as much paint? What if we wanted to mix as much paint as it needed to paint our bedroom, or our house, or something else? And that's where we transition from ratios into ratio tables. So instead of like saying mixing paint once, we want to mix a lot of paint. And so now with ratio tables, we're going to create a table, as you can see here, cups of lemonade, cups of iced tea, total cups. We're going to create tables that will help us figure out how much of what part to mix for making different quantities. Okay, what if we only wanted to make half this much? Well, if we wanted to make twice this much, we'll talk about twice first. Twice this much, we would want to have 8 parts blue and 6 parts green, because twice 4 is 8 and twice 3 is 6. So if we were making twice as much, it would be 8 parts to 6 parts. Now if we wanted to make half as much, it would be 2 parts blue to 1.5 parts green. Okay, so half of 4 is 2. So if we're making half as much, that would be 2 parts. Half of 3 is 1.5. So that would be 1.5 parts. Okay, so we're done with 5.1 notes, and we'll switch over here to this one, and I will enlarge this back to regular size again. In fact, I'll make it even bigger, make it easier to read. Okay, so it says activity 1, making a mixture. Work with a partner. A mixture calls for 1 cup lemonade and 3 cups iced tea. How many cups does the mixture contain? Okay, 1 cup lemonade, 3 cups iced tea. So how many cups? Well, 1 plus 3 is equal to 4. For every 1 cup of lemonade, there are 3 cups of iced tea. B, how do you make a larger batch of this mixture? Describe the procedure and use the table below to organize your results. Add more columns to the table if needed. We're not going to need to add more columns. Okay, so if we went with the starting amount, 1 cup of lemonade, that would mean 3 cups of iced tea, and that would be 4 cups total. Well, let's double this. So we'll say 1 times 2, because we're doubling it, is equal to 2. 3 times 2 is equal to 6, and 2 plus 6 is equal to 8. Okay, we've doubled it. We multiplied each by 2, and when we add those up together, we get 8. And of course, we see that connection here. So I'm going to triple it. So that would be 3 cups of lemonade. That would be 9 cups of iced tea. And that would be 12 total cups. What if we wanted to cut this in half? That would be 1 times, and I'm going to use my fraction, so insert equation. I'm going to click up here, math operations, AB, 1 times 1 over, oops, two. Whoa, how did that happen? I want to go back up, making this harder, is equal to 1 equation. 1 over. Come on. 2. Okay. And then this would be 3. So 3 times, I'm going to just copy and paste this. Copy, paste is equal to 1 and, oops, new equation, 1 over 2. Does that make sense? So we have 1 times 1/2, which is equal to 1/2. I'm going to just drag this a little bit wider. 3 times 1/2 is equal to 1/2. And so then 1/2 plus 1 and 1/2 is equal to 2. Does that make sense? Okay. Do we need to do more? Let's do one more. Let's multiply this by 10. So 1 times 10 is equal to 10. 3 times 10 is equal to 30. And 10 plus 30 is equal to 40. And again, I'm going to make this a little wider. This a little wider. And let's call that good for now. I don't think we need to keep doing this. C. Which operations did you use to complete your table? Do you think there's more than one way to complete the table? We added and multiplied to complete the table. There, we could have divided instead of multiplying by a fraction. What this means is that on this case here, where we multiplied everything by 1/2, we could have just divided everything by 2. 1 divided by 2 is 1/2. 3 divided by 2 is 1 1/2. Okay? But we still would have needed to add. All right. D. How many total cups in your final mixture? How many of those cups are lemonade? So in our final mixture, we had, where did it say total cups? We had 40 total cups. And lemonade, there were 10 cups of lemonade and 30 cups of iced tea. All right. Compare the results with those in your other group in your class. Turn and talk to your partner and compare the results. Well, Mr. Adams, what did you think? We got 10 cups of lemonade and 30 cups of iced tea for a total of 40 cups. You know what? I got the same thing. Great work, Mr. Adams. That was incredible mathematics. Okay, good. We completed this. E. Suppose you take a sip from every group's final mixture. That seems like a great way to pass along a coronavirus. I don't recommend you actually do that. Do you think all the mixtures should taste the same? What do you think? Do you think all the mixtures should taste the same? Do you think the color of the mixture should be the same? Explain your reasoning. Well, I think that if each mixture is made from this ratio table, meaning they all have the same ratio of parts, then they should look and taste the same. All right. And we just explained our reasoning. F. Why do you think it's useful to use a table when organizing the results in this activity? Explain. It's useful to use a table because then we, one, make sure we did it right, and two, we can find out the ratios for many different amounts. Okay, we're going to pause this video for now because that's moving on to activity 2, and this video is already almost 12 minutes long, which is far too long for a video. But I'll see you soon in the next one.